This is my final segment of the F-bomb series. I'll finish the fabrication of the fuselage, then I'll ship it to Aaron at the 6061 channel. He will cap the tail cone, make the tail fins, and machine a deluxe bulkhead. It wouldn't surprise me if he has some other tricks up his sleeve too. Aaron has one of the most fascinating welding and fabrication channels on YouTube, and I've gained tons of knowledge from watching his videos. He always includes his unique brand of humor in the programs too, which makes them fun to watch. We want everyone to understand that this so-called bomb will not hurt anyone. We're just having some fun with a name that puts a smile on everyone's face. I thought long and hard about different ways to hold these parts together, and here's the plan I've come up with. I'm going to make a ring that fits inside the front portion, and this will be held in place with 12 screws. I'm going to use button-head stainless screws, which look very much like rivets, and the ring will have a flange on it for two reasons. One is to give it strength, but also there's going to be a bulkhead that separates the front part from the back part, and this flange will provide the mounting point for that bulkhead. With the ring in place, I have a locating surface that will hold the rear portion very snugly, and then the rear portion will have its own series of 12 screws holding it to the ring. So I think this will give me very good alignment all around the perimeter of both parts. So the next step is to do a very careful layout of the part that will become the actual ring. I've cut a blank of metal to size, and I'll start doing the hole layout for the first row of screws. So I'm going to be working on both sides from a center line, and the hole spacing I need is 3.122 inches. So a convenient way to get that measurement is with a dial caliper. So I'll set the caliper to half of that, which is 1.561 inches. And I have a center punch mark right in the center. I'll put a small scribed line on both sides of center. Then adding another 3.122, we get to 4.682. And again, I'll work on both sides of center. So the layout of the whole centers is done. I'm going to use the center punch to accurately mark the centers. And I'm going to set my caliper for the hole spacing. So I'll set this to 3.122. And I just want to be sure that I'm marking on the correct mark. This sheet of metal has some scratches on it, so I don't want to get fooled by the scratches. So now it's time to make the holes. I'm going to use self-clenching nuts in each of these holes. These are a press fit, and they have to go into a precisely sized hole. The hole can't be any larger than 213 thousandths, which is a number 3 drill bit. It's always best to punch holes when you can. I don't have a punch that size, so I'm going to punch it a little bit smaller with a 3/16 punch, which I have, and then I'll use the number 3 drill bit to open it up after that. I'll start by punching all the holes to 3/16. All the holes are punched. Now I can open them up with a number 3 drill bit. I have to be very careful to leave the top edge of these holes crisp, because when the threaded inserts press into place, it deforms the top edge of the hole, and that's what holds the fastener tight. So now I'll bend a 90-degree flange on the front edge. So that does a great job of making the flange. Now I can use the shrinker on this edge to pull it into a circle. This is the template I'll be using to check the shape. So I'll take this just a little bit at a time. I'm starting close to one end and working toward that end. I'll do the center of this last, and you'll see why that's important in a minute. So I want to check the shape as I go, testing it against this template. It needs to go a little bit more. It's better to sneak up on the shape that I want rather than be really aggressive and overdo it. So I have a nice curl. Let's check it against the template. So it needs more curl everywhere. So I'll continue shrinking it. I'll test it again. So I've overshrunk it in most places. Looks like the worst area is right here. And the stretcher I put on my table. So I'll start stretching this out. And I'll check it frequently against the template. Just a couple more stretches and I think we'll be done on this side. Okay, we're right there. So on the area that I've worked, the outside of the metal is matching the outside of the template just about perfectly. So I'm going to switch to the other side. I'm saving the center for last. So we'll start a certain distance from the end. So let me show you where we're at. The fit is actually quite good. So we'll work more toward the center now. So that's probably a pretty good point to stop. So I will need to trim these ends so they no longer overlap. So after doing a little more adjusting, this is fitting my template just about perfectly. It's time to install the self-clenching nuts. The size I'm using is 832, and these nuts are actually kind of an engineering marvel. All you need to do is to press them into place in that tightly fitting hole, and they really stick well. So there's a bunch of teeth around the edge of the fastener, and there's a little recess above the teeth. And when you press it into place, the metal deforms to get a very tight grip on the fastener. So I'm going to use a vise to push these into place. I'll get the first insert nestled into its hole. And then I've made a small spacer that will push that insert into place. And to get enough leverage on this, I need to use a little cheater bar on the vise, but it presses into place pretty easily. And I should emphasize that you cannot hammer these into place. They really need a gentle squeezing force. So we'll go all around the perimeter of this ring and install the fasteners one by one. So I have all the self-clenching nuts installed, and that really does make a nice clean installation. So the next thing I want to do is I'm going to sand the outer edge of this because it's not perfectly flat. When you make a curved shape out of an angle with the shrinker, it puts a little cupping in the face of the metal, and also pressing these threaded inserts into place has caused some local deformation. And I want this to be perfectly smooth so the front half and the back half of the bomb align with some precision. So the next thing I'll do is to sand these edges perfectly flat. So the edges are nice and flat now, and I can start putting the pieces together. So I'm just about ready to fit this ring into place, and here's my strategy for pulling it tight against the sheet metal. So I'm going to start working opposite the gap on this. I'll get this part centered, and then I'll get this clamped into place tightly. And then when it's tightly clamped, I'll use a transfer punch to mark the hole centered from the back side. So I'll punch and put screws through the first two holes, then I'll put more clamps on this, and then I'll mark the centers and punch the holes for the next two holes, put screws in those. Then I'll mark the centers for the next two holes, and so on and so forth. So as this gets pulled tighter and tighter, I know this gap will get larger. I'll deal with that gap later on. But this should ensure that this ring is pulled up as tightly to the skin as I can possibly get it. So there's one more thing I need to do. I want this ring to be centered from front to back. So I need to mark a center line on this ring so I know how deeply to set it into place. This is a homemade marking gauge I've made, and I've set it so this point is exactly halfway between the front surface and the back surface of the ring. And I can adjust this by bending this pin a little bit. So it really is adjustable. And to make the line more visible, I've used a Sharpie Magnum marker to put a dark line on the metal. So let's go ahead and get this scribed. So I'm going to fit the ring into place, being very careful to align the scribed line with the edge of the sheet metal. That looks pretty good right there. And now I'll lay this down so I can transfer punch through the nuts. So the punch has a point right in the center of it, so I will align that point right in the center punch mark I made and punch the holes. Now I can assemble this. And I'll get the ring clamped into place in preparation for doing the next two holes. And I'll continue in this way until all the holes are punched. I've made all the holes for the mounting screws, and this ring is pulled up nice and snug all around the perimeter. I'm very happy with how that's come out. And now I want to deal with this gap at the end. I'm going to put a block into place, and this has several functions. One, it will fill the gap. Two, it'll tie the ends of the ring together to make it more rigid. And three, I'm going to put a threaded hole in this so I can mount this to a base or hang it from a cable. So I'm going to get this positioned accurately. I'll center it between the two holes. Then I'll clamp this into place. And I can tack weld this block into place in position. Then I'll pull this ring out, finish weld the joint, sand it smooth. Then we'll be ready to start fitting the front end of the bomb into place. So I've welded this block into place and smoothed the weld. And I want to do one more thing before I put this ring back in the fuselage. I plan to make a bulkhead that separates the front half from the back half. So I've cut a disc of metal here. This will be the bulkhead. And I've laid out a 6-hole pattern. I want to transfer this hole pattern to the ring and put some threaded inserts in the ring. And because I laid these holes out by hand, there's bound to be some inaccuracies. So I put a little notch on the bottom of this that will align with the hole in this block. So I'll center this disc by eye. I'm just making sure the border is even all the way around. Then I'll use a transfer punch to mark the center of the first hole. So I'm going to install the threaded insert in this hole first before I do the layout on the rest of the holes. I have the first insert installed, so I'm going to put the plate into place, put a screw through the first hole, then again I'll get this centered around the edge and use a transfer punch to lay out the hole the farthest from the first hole. And now I can install the threaded insert in the second hole. Now that I have two threaded inserts installed, that'll locate this disc precisely. So now I can lay out the center of the rest of these holes. So I'll drill these holes out and install the threaded inserts. So it's time to join these two parts together. You might remember that I left this joint unwelded in this section so I could fine-tune the fit. As it turned out, I had to break the last two tack welds to allow this to spread apart a little bit to fit snugly over the ring. And the next thing is, I thought I would have these parts fit tightly together, but I've decided against that. I've decided to give it a 1/16 inch gap for a couple of reasons. One is that if it's a tight fit, if there's one spot that has even a 10,000ths of an inch gap, that's going to stick out like a sore thumb. But if it has a gap that's mostly 60,000ths of an inch, but goes to 70 in one spot, you won't even notice that. And another reason is, because these are a snug fit and there's no handle on the top part of it, it's going to be hard to pull these apart if they were snugly put together. So with a 1/16 gap, I can get a small tool in the gap to pry them apart. So to create that gap, I've made a simple ring that has some flat spots on it, and these 3 flats are 1/16 of an inch thick. So let's get this positioned into place, and then when I put the nose into place, it'll be spaced up a 1/16 of an inch from the tail. So let's get this positioned. Then I'll bring it down until it's tight on all 3 of these pads. And I'm going to start drilling the holes that will hold the nose piece to the tail piece. And I made a little fixture for this so the hole spacing will be very consistent. So the way this works is there's one screw that goes through this hole, and I'll put that into place. And then there's another hole for a second screw. And then there's a tiny hole right here, which I'll use for a pilot drill. So with the pilot drill, I've gone through both the nose piece and the ring inside. Now let's disassemble this. And this pilot hole will be excellent for centering the punch. So the male punch has a little point right on the center of it. I'm going to get that little point right in the center of the pilot hole. Then when I punch the hole, it's positioned very accurately. And we'll punch the hole in this portion as well. Now we can reassemble these. Okay, I think we have a good fit up now. I'll put a screw in that hole. I'll just put nuts on the back side of this for the time being. I'll put these other 2 screws back into place. And I'm going to move 3 screws over for the next one. So we're going 1, 2, 3. I'll bring the little fixture over to this side. Make sure everything is down tight against these 3 spacers. Then we can drill the next hole. We'll disassemble this. And now I can punch the next holes. And I'll continue in this way until all of the holes are punched. Now that I've tightened all these screws, pulling everything tight against the ring, I'm going to re-tack weld this joint. So I'll pull the last of the screws out, and this will be my first opportunity to use my little spreader tool to disassemble this. So this fits in that small gap, and I just need to pry it apart, and it pops that right off. This tool was made for removing trim on cars, and it's perfect for this application. So now I can finish this weld. And now I can fusion weld this on the inside. So I'll sand the weld flush on the outside now. And then I'll planish this weld until it becomes smooth on the inside. Now I can file this, lift up any low spots, sand it, and blend it in with the rest of the nose. So I finished that last seam. Now I'm ready to move on to making the cap for the nose. We already have a buck that shows the contour. I've also made a template that will help during the shaping, and I need to decide what size blank of metal I need to start with to make this part. Measuring across the flat, I get a 6.5 inch dimension. I want to add about 3/4 of an inch on either side, so that leads me to start with an 8 inch disc. So I'll use the shrinker to pull the edge down to 45 degrees. And I'm using a depth stop on this machine so I can ensure that I shrink the same depth each time. I've set it to 3/4 of an inch. So I'll just work around the edge of this, and every time I push on the foot pedal, it pulls that edge down. So I've made one lap around this part, and let's check this with the template. So I'm not quite to 45 degrees yet. So I'll make one more lap to bring it down to 45. Okay, I've made 2 laps around this. Let's check it with the template. And it looks like I do have enough angle now. Try this on the part, and you can see it's coming along nicely. So I'll bring over the English wheel and start doming the center. I need to select the proper wheel to use with the English wheel. So using this radius gauge, I can see that I need something close to a 4-inch radius. So the wheel that I have in this set that's closest is 3 3/4 inch radius. So that's the one we'll use. So I'll put this in the machine. Then I'll put the metal between the wheels and bring the lower wheel up and just start shaping this piece. So I'll pull this out to check the progress. So it certainly has domed up quite a bit. Of course, we have a long way to go, but let me show you how much doming I've created in that first pass. About 3/8 of an inch. So I just need to do this again and again and again until I have the depth that's needed. I'll check that again. So you can see I'm getting constantly more doming. I'd say it's domed up about 5/8 of an inch. But when we compare it to the 4-inch radius, you can see we have a long way to go. So I'll just keep wheeling. So I've been wheeling for about 20 minutes. And if we check it with the contour gauge, it looks very close. But a more realistic way to check it is with this template I made. And we are close, but it still needs to go about 1/4 of an inch. So we're on the right track. It just needs more time spent in the wheel, doming the part up. So after a few more minutes wheeling, I believe I have the depth I need. And I've lightened the pressure between the wheels to give it the final finish. So let's test it into place and make sure that we have what we need. So I'll get my contour template into place. And I'd say that's just about perfect. So now I can trim these parts and tack weld them together. So I trimmed a little off the bottom of this dome to clean it up, and I have it held in place with a weight. And I'm going to put a witness mark on this so I know which way it lines up. And then I'll scribe the dome against the next piece. Now I'll trim this edge and tack weld the parts together. The joint is trimmed and fitted and ready for the tack welds. The joint is fully tack welded, and I've worked the seam with a hammer and dolly to make sure everything is level, so it's ready for the finish welding. Now we'll fusion weld the inside of the joint. Now I'll use the planishing hammer to crush the weld flat on the inside. The planishing hammer did a great job of crushing that weld flat, but the metal's still a little bit wavy in the weld area, so I'm going to use hand tools to smooth it out. I took the time to make a little fixture to hold this part, and I'm glad I did. This part is pretty difficult to get a grip on, and there's nothing worse than trying to hammer on a moving target, so this holds the part very securely, and it's completely open on the back side so I can get inside with the dolly. And I've chosen a dolly that's a very close fit to the shape of the nose, so that'll make the smoothing easier. I'm working the whole surface with the hammer and dolly. I can lower any high spots by hammering off dolly, and I can raise any low spots by hammering on dolly. I've worked the whole surface with a hammer and dolly, and I'm very happy with the smoothness of the finish. I'm going to hold this up and rotate it so you can see from the reflected light how uniform the contours are. So this is ready for the final sanding. So I'll get it back in my fixture. I'll put my safety gear on, and I'll go over the surface with 240 grit sandpaper. So I finished smoothing the whole surface using a disc sander. The next step is to go over this with an orbital sander. So the orbital sander has given this a nice uniform finish, but I want to take it one step farther, so I'll give it a light grained finish by using a green Scotch-Brite pad. So both parts have a nice grained finish, and now it's time for the final assembly. After many hours of careful work, this is the part I like the best, putting the pieces together for the final time. So let's start with the nose piece. I'm going to tip this upside down. I've made a little circular holder for this. And to make it a little bit more stable, I'll put a sandbag inside it. And all of the pieces have a locating notch on them, so there's a notch on this part and on this part. And the ring that fits inside here has a threaded hole that aligns with that notch. So let's get this fitted into place. And to help with the alignment, I'm going to use a tapered punch. That'll help draw this around to align each screw hole. So I'm going to put one screw in here, and I'll leave these loose in the beginning. I'll move a few screw holes over, start another screw, start another screw, one more near the back. Now I can fill in the empty spaces between the screws. So this will be the last screw on this row, and I can go ahead and start snugging these up now. Okay, all of these screws are tight. Now I'm going to put the bulkhead into place here, and I need to remove the sandbag before I do that. So I will align the notch on the bulkhead with the screw hole in the ring. Now I can tighten these screws. Okay, now let's join this to the tail piece. I'll move this to the center of the table. And again, I need to align this notch with the screw hole in this part. So I'll just get this started, making sure the screw holes are aligned pretty well. Just start that into place. Now I want to maintain a 1/16 gap between these. So I'll get my spacer ring put into place. Now I can tap it down tight against the spacers. Then I'll use my little scriber to align the holes. And I'll start fitting the screws into place. Okay, now I can remove that spacer ring and start fitting all of the screws into their holes. Okay, so all the screws are tight. Let me clear off my table. So ladies and gentlemen, here is the finished F-bomb. I had a ball with this project, and I hope you learned something from watching the process. So I'm going to ship this off to Aaron at 6061. He'll apply his magic to it and give it the finishing touches. So thank you for watching this series, and I look forward to seeing you next time. If you enjoy my videos, please like, subscribe, and click the bell to be notified when I post a new project. If you like, you can support these videos through Patreon. Just click the link at the end of the video. I'll see you next time.